Alright guys, in this video we're going to knock out questions 4 and 5. Now it says here, a single card is drawn from a standard deck of cards. Find the probability that it is a king or a red card. Something that I told you guys for exam number 2 is when you're dealing with cards, and I put it in the asynchronous part, which you guys need to view. When you're dealing with cards, do not double count the overlaps. On too many exams, I witnessed the overlap being counted twice. And we do not want to do that. Now, I'm going to answer this question the same way I did it in Chapter 10, Section 1. And then I'm going to answer the question using the addition rule. It is a king or a red card. These are my kings right here. These are my red cards. It says the word or. So it can be a red card or it can be a king. There are 52 cards in the deck in total. So using the way we did it back in Chapter 10, Section 1, let's find the probability of a red or a king by counting the options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 11, 12, 13. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Now, you counted the King of Hearts and the King of Diamonds already a part of the red cards. Do not count them again when you want to look at the kings, because they already have been included. So this is number 27. Let me put that in a different color. Number 27, number 28. There are a total of 28 cards that are either a king or a red card. So the probability of a king or a red card is going to be 28 over 52. Reduce that fraction by dividing the numerator and denominator by 4. That equals to 7 over 13. And once again, that is doing it the way we did it in Chapter 10, Section 1, by using the diagram itself and visibly looking at the outcomes without double counting. We're going to use the addition rule now. And I'm going to write the addition rule right here. The probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. And once again, we know we're using the addition rule because of the word or that is present. Now, we're going to call my king event A and my red card event B. So the probability of a king or a red card using the format is going to equal to the probability the card is a king plus the probability the card is a red card minus the probability the card is a king and it is red. And the reason why we're subtracting at the end is to account that, is to take into consideration of eliminating where we have double counted. Let's reset. Well, at least the inside, so I have a better picture to look at. How many cards in my deck are kings? I have 4 kings in my deck. So the probability of a king is going to be 4 out of 52. Plus, how many red cards are in my deck? Half of my deck is red. So I have 26 red cards out of 52 cards in general. Minus. See, this is why we need to use the addition rule, because now we can account for the overlap. The probability that the card is a king and it's red. And means intersection. Where does the two events intersect at? They intersect right here. Those are red kings. There are 2 red kings. So that's minus 2 out of 52. Same denominators, combine the tops. 4 plus 26 is 30. 30 minus 2 is 28. So that's 28 out of 52. And that is 7 over 13. Let's continue. Number 5. The Venn diagram shows the memberships for the Spanish club and computer club. Note that Elsa is outside of the circle since she is not a member of either club. One student from the class is randomly selected. Let A denote the event. The student is in the Spanish club, so that's event A. And let B denote the event the student is in the computer club. A, find the probabilities of the events below and write each probability as a single fraction. What I'm going to do is I'm going to keep that right here, and I'm going to answer the questions on the side. The probability of A. Now remember, A denotes the event of it being a part of the Spanish club. Before I continue, I want to know how many students are in total in this Venn diagram, including Elsa. When I add up the number of students that are in the Venn diagram, there are 14 students. If you ignore Elsa, that means you'll get 13, which will be the wrong sample space. Out of your 14 students, how many students are a part of the Spanish club? Some people will say 6 students because you will only look at these 6 students right there. However, that will not be correct. Do not make that mistake. It says Spanish club, or event A, which is Spanish club. That is the entire circle. There are a total of 8 students that are part of the Spanish club. So the probability of event A is 8 out of 14, which is reduced to 4 over 7. The probability of event B. Now, that's going to focus on the computer club. Out of a total of 14 students, how many students are a part of the computer club? And if you count, that is 7 students are part of the computer club. So the probability of B is 7 out of 14, which is 1/2. The probability of A and B. Out of 14 students, how many students are in the Spanish club and the computer club? This right here, the intersection, is Spanish club and computer club. That is 2 students out of 14. So the probability that they're part of the Spanish club and computer club is 2 out of 14, which is reduced to 1 over 7. The probability of A or B. The probability the student is in the Spanish club, or or the student is a part of the computer club. So it can be the Spanish club, which is here, or it can be the computer club, which is right here. Remember, or is union. If I unite these together to form one overall set, and I count how many students are in either club, that is 13. 13 of the 14 students in the Venn diagram are in either the Spanish club or the computer club. Do not confuse or and and. And means applicable to both, or can be one or the other, including the option for both. And let's do the last part, which says the probability of A plus the probability of B minus the probability of A and B. The probability of A plus the probability of B minus the probability of A and B. Let's compute that using the non-reduced fractions. The probability of A is 8 over 14. The probability of B is 7 over 14. The probability of A and B in its non-reduced form is going to be 2 over 14. Same denominators, combine the tops. 8 plus 7 is 15. 8 plus 7 is 15. 15 minus 2 is 13. So that is 13 over 14. And if you notice, this answer is the same as the probability of A or B. Because once again, this is the addition rule. What does the probability of A plus the probability of B minus the probability of A or B equal? That equals to the probability of A or B. And we should know that by now. So when we are computing this part right here, we can automatically just know it's going to be 13 over 14. All right, guys, that is it to this video. Hope you enjoyed it. Hope you understood it. I'll see you in the next one, and that'll be it for the addition rule. Take care.